So we're gonna start off with this one. This is from your activity, question number 8. I just had a feeling, uh, like maybe we're not making the connection or putting things together. So the question is, at what point is the tangent to f of x equals x squared plus 4x minus 1 horizontal? Before we even get into it, guys, this is a quadratic. If I just draw a quadratic function, this is opening upward. There's only one location where I'm going to have a tangent that is horizontal. And that's going to be at the vertex. So one way to do this without any calculus is to just draw a little thing there. And then look, you can be like, that's a horizontal tangent. Horizontal tangent. And then you can say, well, I know it happens at the vertex. I'm just going to A comma B. Vertex. Let's find the vertex. Hopefully you remember from your algebra days, vertex form, sometimes they call it standard form, for a parabola is y equals y, a parenthesis x minus h close it squared plus k. Well, I guess I should probably change the AB to hk, right? H comma k. Where hk is your vertex. Do you guys remember that from your algebra 2 days? All right, so if I take this function, because I didn't tell you to use the limit formula. Obviously, I want you to do that route, but you don't have to because it doesn't tell you that explicitly. If I go f of x equals x squared plus 4x minus 1, and my whole goal is just to find that coordinate, because that's what it says, at what point is the tangent horizontal. So I can just do completing the square to get this to look like that. Chav, how do you do that? Okay, well, I'm going to expand it. Chav, you haven't done anything other than space stuff out. That's right, because I'm going to look at this 4, and I'm going to complete the square. So 4 divided by 2 is, and 2 squared? 4. Now, if I add 4, I got to subtract 4 for balance. I guess I should change the color. Plus 4 and minus 4. This one's for balance. Bless you. Bless you. And that 4, I got it by doing b divided by 2, and then I squared it. So here's my b, I divided by 2, and I squared it. Are we okay? Chav, why do you do that? Well, this is called completing the square, guys, and when you do that, you get this, x plus 2 close it squared minus 5, and it works because this expression here is the same as this one. So where's your vertex at? Negative 2, negative 5. If I were to expand this, I would get this expression. And that's what you did a whole bunch of in Algebra 2. Look, if I expand it, x times x squared. X times 2 is 2x, but don't worry, I see. 2x plus 2x is 4x. And then 2 times 2 is 4, minus 5. Just bring that down, and then look. X squared plus 4x minus 1. And that expression is the same as this expression. So you didn't change anything. You just made it in standard form or vertex form, because some people call vertex form standard form and vice versa. And there it is. So my vertex is at negative 2, negative 5. What's up, Kyle? You talking about b over 2a? Well, okay, see, the problem, where did that b minus 2a come from? Where? See, but do we know where it came from? Like, it came from completing the square. This is the formula, but we didn't call it that. b over 2a. The problem with formulas is, are you going to remember them forever? It's the logic that I want you to know. You can use a formula. But
I'm just saying, would it work if I did this?
Yeah, it would work. It should if you do it right. Right? Now, I don't want you guys. I just did critical thinking. I just did completing the square. Chav, what did you do? All I did was I turned this 3 terms into a binomial with a square on it plus k. I just made it look like this. How did I make it look like that? By doing something called completing the square. Chav, why does it work? Because when you complete the square, it turns a trinomial into a binomial. I don't understand what you're saying, Chav. Okay, look. 6 squared plus 6. I'm just making this up. Bless you. Don't write anything down. I'm just making this up. I'm gonna say 7. So check it out. If I wanted to find something equivalent to this, but with that looks like this guy right here. This is all made up. I'm gonna take these two and I'm gonna go x squared plus 6x and I'm gonna put the plus 7 here on the side, and I'm gonna create a third term to get a perfect something that's gonna reduce to a binomial with a square on it. How do I do that? I take that 6 divided by 2. And it's 3, and then I take that number and I square it. What's that number squared?
9.
I put plus 9 and I put minus 9 for balance. Look, these 3 turn into this, x plus 3 with a square on it. If I take the x plus 3 and I square it, I get x squared plus 6x plus 9. And then this 7 minus 9, that's minus 2. And this expression is the same as this one. And if you put a y in front of it, well, oh, okay, my vertex is at negative 3, negative 2. Do you guys see what we did there?
What is that word? What's this next to balance?
Oh, the negative 9 is for balance because you can't just magically add a number, because you're adding a number, so you got to subtract that same number to keep it the same. What's up, Zamora Johnson?
I see, I get where you got -5 from, but where do you have the 2 from in the vertex?
Are you talking about what I have in black?
No, in red.
Oh, in red? I got the -5 from right here.
No, the -2.
Oh, from right here. This is my transformations. So from algebra 2, yeah, so calculus is not going to be our demise. It's going to be our algebra. Remember that from algebra, guys, this is what you call a parent function. And then if you want to move it left or right, then you go x minus a close it squared. And then if a is positive, x minus 5, then you move 5 to the left. 5 to the right, sorry. If a is negative, negative times negative is positive, you move. Does that make sense? So if I were to tell you x minus 3 close it squared, that moves 3 times to the right compared to x squared. So if I have right here x plus 2, that means I move 2 to the left. So you move to the left. You know what I mean? Yeah, I might have said, was talking too fast. All right. Are we okay, guys, with what we've done so far? All right. I want to talk, let's see. Oh, yes, this one. I'm still in this question because here's what I would have liked for you guys to do. All you know right now is how to find a tangent slope. That's all you know how to do right now. There's 2 ways to do it. That's what we're going to practice on. What's one way that you know how to do it? Like this. You go limit as h approaches 0, and we're going to talk about this one right here, f of a plus h minus f of a all over h. This acts like y2 minus y1 over x2 minus x1, where the h is nothing more than a delta x. And don't worry, we're going to talk a lot more about this. Okay, you know what? Let's talk about it right now. I don't see it. I'm just going to do a quick Google. A is some x value. And h is my delta x. Yeah, we've had the same talk 2 days in a row. Secant to tangent line Desmos. Hopefully it's the first one. Yeah, see, this is the one that we saw yesterday. Look, guys, a is some value. Look, a is some x value. Here's my h. And look what's happening to my secant line as I get closer and closer to A. Right at A, bam, that turns into a tangent line. Do you guys see what's going on? Houston, do you see what's going on? So I have a secant slope, I have a secant line, and as I get closer and closer to A, it turns into a tangent. So all you're doing is making your delta x approach 0. So that's what this is right here. F of a plus h, like y2 minus y1 over the delta x. Are we okay? All right. I don't have an a value. That's what we're looking for. Chab, what are you talking about? I'm looking for my x value, which is a, which is h. I know. I hate confusing you guys. I'm looking for a specific x value. I'm looking for the vertex. But that's what we don't know. Obviously, we already know it. It's this point right here, -2,5. Let's see if I would get it if I do this. So, Chab, what are you doing? What's my slope of a horizontal line? 0. I'm going to set that equal to 0, and I'm going to solve for x. So I'm going to do this. I'm going to do f of x plus h minus f of x all over h. I'm going to equal it to 0. So I already know what f of x is. F of x is x squared plus 4x plus 1. Oh, minus 1. I would have gotten it. I might have been safe. F of x plus h is x plus, I'm just substituting wherever I have an x, I'm just substituting the expression x plus h. X plus h squared plus 4 times x plus h minus 1. Have I confused anyone? All I'm doing, guys, is I'm trying to solve for the expression of f of x plus h. Right now with this right here. Yes. Yes. I'm trying to find the slope of a tangent line of where the slope is 0. So I'm trying to find the x coordinate of where that happens. And I better get negative 2. So x times x times h, hx. Let's say xh. How many of those am I going to have? So 2xh, h times h, and then plus, to distribute this, 4x plus 4h minus 1. It doesn't look like anything combines. So here we go. Limit as h approaches 0 of this expression, x squared plus 2xh plus h squared plus 4x plus 4h minus 1 minus parenthesis, what's my f of x? Yep. X squared minus plus 4x minus 1, and all this is over what? H. I'm going to distribute. So this is going to turn to a, let me drop this. This is going to turn to a minus, and this is going to turn to a plus. Are we okay? Let's see. What zeros out? X squares, the 4x's, and the 1's. What can I factor out in the numerator? An h. Limit as h approaches 0. Here's my h factored out. 2x plus h plus 4. Close it all over h. What's going to cancel? H's. And then look, if h approaches 0, I get a function. I get an expression. 2x plus 4. And what did I tell you that I want this to equal? 0. I'm going to solve for x. Remember what this is telling me. So this is I'm going to finding the x value where the tangent slope is 0. That's what this is telling me. Minus 4 minus 4, 2x is negative 4. Divide by 2, x is negative 2. Did I get the same answer as before? Yes. Chav, how do you get the y value? Well, you have that negative 2, plug it into the original. F of negative 2 equals negative 2 squared plus 4 times negative 2 minus 1. 4 minus 8 minus 1. Difference between 4 and 8 is 4, but the 8 is larger, so negative 4 minus 1, negative 5. There it is. Point where tangent line is horizontal is, parenthesis, negative 2, negative 5. Maybe this is the harder way. Maybe it's easier with algebra. But do you see what we're doing? Don't worry, it's all going to make more sense right now because we're going to go in depth. I'm going to go as slow as I can. All right. This is the main thing, and after this, yes, you can be a robot and get all these answers correctly. I don't want you to be a robot, though. You can trick me, like, oh yeah, I know what I'm doing. You can trick me because it's the same formula over and over, and if you just use the formula, you'll get your answer all the time. So if you're like, Chav, just tell me a formula. Okay, I'll give you a formula. It's this one, f of x plus h minus f of x over h. Just use the formula over and over again. You'll always get your answer for your instantaneous rate of change or your slope. But I want you to understand it. All right, so ready? So I have this function. So turn the page. It says I have this function x squared over 6. And it says find a tangent line at x equals 2 for this function. We'll use two different methods, which are essentially the same thing, just different ways of thinking. Find the tangent. Okay, well, for the tangent line, I need two things. I need what and what? slope. Okay, the point I can get real quick. At x equals 2, I'm just going to plug in a 2 in there. So f of 2 equals 2 squared over 6. 2 squared is 4. 4 over 6. So that reduces to 2/3. So my point is 2 comma 2/3. Are we okay? All right. Okay, so here it is. Finding tangent slope. And I'm going to put parentheses. I'm going to call it method 1. And I'm going to say preferred. This is our preferred method. Preferred. It's not the only way, but it's the preferred. The preferred method is to say limit as h approaches 0 of f of 2 plus h. So I'm going to go 2 and a little bit past it. And I'm going to subtract f of 2. And I'm going to divide all that by h. Remember where h is your same thing as delta x. I'm going to give you a visual. So let's just talk. And then you guys tell me where we have issues. And there is no shame. Tell me. So look, here it is. It's a parabola. It's that exact parabola, x squared over 6. And all I'm doing, do you see that h? Look, I'm just messing with the h. So right now my h is 2.6. You guys see that? And now look, as I get closer and closer, so right now I have a slope, but it's a secant slope. As I get closer and closer, see how it turns into a tangent right there? But you can't divide by 0, so that's why we can't just plug in h equals 0. So I'm going to find that slope. And I know right now it's not finding a slope. It's just giving me a line. It's just giving me a visual. So let's start from scratch. We can do this from scratch. We have confidence. Look, Desmos.com. And this is unrehearsed. I'm just going to type in the same function. F of x equals x, parentheses x squared over 6. Okay, x squared over 6. All right, what am I going to do? So I'm going to put m1 equals, and I want to do what we did over there. So I'm going to put a little fraction, and I'm going to do f of 2 plus h minus f of 2 all over h. Bless you. Are we still okay, guys? Let's see. I'm going to put add h. No, I don't want this guy. I don't want this guy. And that guy. Yeah. All right. So here's my h. And I need a table because I need to see the values. Maybe there's an easier way. I'm just thinking right off the top of my head, guys. So what am I going to plug in? X values. And I want to compute my M1s. All right, guys. Give me your A game. Give me your A game. So why is there a number already there? Hold on. Oh, what is it doing? Oh, okay. So I haven't given it my h values. So let me put h in here. And let's see. Can I change it to 0.5? Hold on, guys. I want to see f of 2 plus h minus f of 2 over h. That's correct. Oh, it's giving me an h value here. Okay, I got it. We got it. Okay, we're good. We're good. So you see this h value? That's my delta x. Yes or no? Look what happens as I get closer and closer to 0. Remember, this is telling my slope. If I get closer and closer to 0, well, at 0, it's undefined. Let me see. Can I animate this? Oh, yes, perfect. Look at this, guys. Man, look how awesome this is. I'm going to go from 1, and let's start it. Oh, come on. I'm going to do my step size as 0.01. And let's see. I'm going to push enter. I'm going to push play. And let's see what happens as I get closer and closer to 0. Look at the M1 here. You're getting closer and closer to what? It looks like 2/3, 0.6. Do you guys see that or no? Maybe it's going too fast. Let's put a whole bunch of zeros. All right, look, let's do it again. So right now my h is getting bigger. So obviously, okay, now here, this is the one I want. Man, how do I slow this down? It's too fast. So 0.67, look, I'll just do it myself. Look at this, 0.72, 71, 71, 70, 7, blah, blah, blah. So maybe I should have chosen a different value than 2. But notice what's happening as I get closer and closer to h equals 0. This is my delta x. It looks like it's approaching what value? It looks like it's approaching 2/3, which is by coincidence the same value as my y value. I didn't want that, but that's by coincidence. Okay, so that means we already know what this answer is, hopefully. It looks like, I'm going to say right here, looks like slope is 2/3. I should have calculated it first by hand. Let's see. 2x, oh yeah, 2x over 6, that's 1/3, and then 1 times 2 is 2/3. Okay, don't worry, you'll be able to do that too in about a week. You can do it really fast. All right, here we go. Ready? I'm going to do it by hand to see if I get that 2/3. f of 2. That's 2/3. F of 2 plus h. I'm just doing this. I'm just plugging it in right here, guys. Hold on. 2 squared is 4. 4 over 6. Yeah, 2/3. All right, I'm just plugging it in here. So I'm going to parenthesis 2 plus h, close it, squared over 6. Are we still okay? All right, here we go. I'm just gonna expand it. 2 times 2. 2 times h. 2h, but I'm gonna have so 4h plus h times h. All divided by. Let me see. Do I see any issues? I don't. All right, here we go. I'm doing this part. Limit as h approaches 0. 4 plus 4h plus h squared over 6 minus 2/3, and all this is over h. Are we still okay? All right. I'm going to get a common denominator in the numerator, if that makes sense. So I'm going to multiply this by 2 over 2. So this is going to be 4 and 6. I guess the original without simplifying. Bless you. Bless you, squared. Are we still okay, guys? Keep, change, flip. Here we go. Limit as h approaches 0. 4 plus 4h plus h squared minus 4 over 6h. Is everyone okay with how I got that? What's going to zero out first? What can I cancel next? One of the h's, or I guess you can factor it out. And then I have 4 plus h, close it, over 6h. Now what's going to cancel? The h's. And what is h approaching? 0. So this becomes 4, 6, which is just... Wow, look, that's my slope. Yes.
Say how you went from 4 plus 4h plus h squared over 6 minus 4 over 6 to 4 plus 4h plus 4 squared back slope. Like, how did we go from that?
From this one to this one? I did the keep, change, flip. I did this. So let me slow it down. So on my numerator, I had 4 plus 4h plus h squared minus 4 over 6 over h, like that. That's like h over 1. So I can say 4 plus 4h plus h squared minus 4 over 6 times 1 over h. And see the h and the 6 group. So if you want to do a side note, a over b over c, if you think that's like c over 1, it's going to be a over bc. Does that make sense, Henderson? Okay. All right, that's the preferred method. Maybe you're going to like this one better because you guys, I think, like algebra, like the algebra thing. All right, method 2. Is there enough space? Yeah, you won't need a lot of space for method 2. Method 2 is to do this. Limit, and I want x to approach 2 of f of x minus f of 2 over x minus 2. Chop, I don't understand what you're doing. Guys, if you have a curve, bless you, think about what I'm doing. I have this point, and I'm going to call that point, you know what? I'm going to call it x comma f of x. And I have another point. And I'm going to call that point, this is not to scale, because I don't want you guys to think, like, oh, I'm going to call that point 2 comma f of 2. Look what I'm doing, guys. Connect those two. If I want the slope of that purple line, okay, give me your A game, guys. Give me your A game. If I want the slope of that purple line, y2, okay, that's fine, f2 minus f of x over 2 minus x. Chav, it's reversed. Okay, it doesn't matter. I could have reversed it as well. You could say f of x minus f of 2, as long as you keep the pattern the same, right? X minus 2. It's the same. Chav, it's not the same. Okay, look, let me show you. 5 minus 3 over, I'm just making this up, 2 minus 0 is the same thing as 3 minus 5 over 0 minus 2. See? Negative 2 over negative 2, that's 1. 2 over 2, that's also 1. Are we okay, guys? Yeah. We're not okay? Okay, so check it out. This is the same as that. And I was kind of tempted to put 2 f of 2. You know what? Let me start over again. Just with this, because I don't want to confuse you guys. And I think with this, I might confuse. Relax. You're fine. You're fine. Look. 2 f of 2 and then x f of x. I haven't done anything crazy. Okay, check it out, guys. You see that blue line or that violet line? As I get closer and closer to 2, as if I make x approach 2, that secant line will turn into a tangent line. Do you guys see that? So that's better. I think for you guys that's an easier visual to see. So f of x minus f of 2. There we go. Now there's no confusion. Over x minus 2. Are we okay? That's exactly what I'm going to do with Desmos. Look at this. I'm going to go to Desmos. See, everything I can do, you guys can do also. And look, I'm just going to go, I'm going to call it M2 equals, and what am I going to do? I'm going to go f of x minus f of 2 over x minus 2. I'm going to create a table. I'm going to call this x, and I'm going to call this guy M2. If I put 2, it's going to say undefined because you can't divide by 0. But check it out. Look what I'm going to do. I'm going to get this x value closer and closer to 2. So I'm going to start at 2.1. And you already know what the answer is. The answer should be 2/3, right? Look at this. I'm going to put 2.01. I'm going to put 2.001. 2.000001. Look what's happening. What's that y value? What's that M2 getting closer and closer to? To 2/3. So there it is, 2 different ways, and I know, like, child, there's a graph there, it's confusing me. Let me turn it off there. 2 different ways to get my tangent slope. Cool or not cool? All right, so let me go back. And after this, guys, you guys are going to be pros. All right, so here it is. That's going to equal, I guess let's do the algebra. So limit as x approaches 2, my f of x is x squared over 6. X squared over 6. Minus, and then f of 2 was 2/3 over x minus 2. Okay, I'm solving. What am I doing? I'm solving this limit. Okay, so here we go. I'm gonna multiply this by 3 over 3. I'm just doing algebra, guys. 3 over 3, 2 over 2. So I'm gonna get limit as x approaches 2 of x squared minus 4 over, let's see, 6, and now that is still over x minus 2. Yes. To get a denominator of 6 in the numerator, because I wanted to combine those. Are we still okay, guys? Look what's going to happen. I'm going to do keep, change, flip, and I'm going to expand the x squared minus 4. That's the difference of squares. Limit as x approaches 2, x plus 2, x minus 2, all over 6 times 1 over x minus 2. Henderson, are we okay? What's going to cancel? Now that I've canceled the x minus 2's, can I do direct substitution? What's 2 plus 2? 4 over 6. That reduces 2? There it is. That's my tangent slope. All right. What is your tangent line? I'm just going to leave it like this. Here's my tangent line. I'll put it right here. Tangent line. Y minus 2/3. 2/3 x minus 2. I'm going to leave it. Yeah, you can leave it like that. Look, if you go to Desmos, I still have Desmos here. And if I type in, let me see if that really is my tangent. Y minus 2/3 equals 2/3 x minus 2. Does that look like your tangent line, guys? No? Oh. I thought I heard you say yeah. No. Look, that's my tangent line. Let me take off the other point because it looks where. What is that blue one? No, this one. Close, 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 close. There it is, guys. It's definitely my tangent line. What do you guys think? Okay. Don't worry. We're done with the hard stuff. The concept is the easy part. I mean, the hard part. Yeah. Did that kind of make sense to you guys of what we're doing? Okay, so all you're doing, so let's test your critical thinking. Look at number 1, and it says find the instantaneous rate of change, same as tangent slope at the indicated a value. So all you're doing is finding your slope or your instantaneous rate of change. Look at number 1, look at that function, the 3x minus 1. Look at it and think about it deeply. Without even lifting the finger, what's my instantaneous rate of change of that function at x equals 5? Yeah, how'd you do that so fast, Miss Kyle? It's a linear function. So the slope of a linear function is always the same regardless. So that 3x minus 1 is also your tangent line because it's going to look the same. So my tangent slope is also 3. Does that make sense, guys? Well, because you just have a linear line. You just have 3x minus 1 like that. If I tell you, give me my tangent here at this point, well, I guess it's just, well, it's tangent at that. It's the point. Every point is its own tangent. Like it's the same line, because it's just a linear line. If you're driving on the road, on a straight road, and you let go of the steering wheel, it's just going to keep going straight. It is, but it's just a linear line. So yeah, if you have a curve, that's a tangent line. But if I told you to find my tangent line of that linear line, I mean, by definition, you know what I mean? Okay. Yeah, the example I was going to give you, if you guys don't drive yet, but there's other factors as well, but if you're turning on a curved road and you let go of the steering wheel, it's going to want to straighten out. So you would go off on a tangent. Okay. All right, check it out, guys. Let's just do both. You're going to get 3. So look, what do I need? I need f of a, so I need f of 5. F of 5 is 3 times 5 minus 1. 15 minus 1 is 14. And I need f of 5 plus h. 3 parentheses 5 plus h, close at minus 1. 15 plus 3h minus 1. So this is 14 plus 3h. And I know, I'm not trying to insult your intelligence. I know you can do this without limit as h approaches 0. 14 plus 3h minus 14 all over h. What's going to zero out first? The 14s. And now that you canceled out the 14s, I have 3h in the top, I have an h in the bottom. What can I cancel out? Are you shocked that the answer is 3? No. You're not shocked. I'm going to change my color to red. I'm just going to do it just because we want to get the practice, guys. I know. You got to practice. Practice makes progress. Here we go. F of a, I already have it. F of 5 is 14. And then f of x is 3x minus 1. So here we go. Limit as h, not h, this time is x, as x approaches 5 of 3x minus 1 minus 14 all over x minus 5. Are we okay? Okay. Minus 1 minus 14 combine like terms. So I'm going to limit as x approaches 5 of 3x minus 15 over x minus 5. What can I factor out in the numerator? So limit as x approaches 5. Here's my 3 factored out. X minus 5 over x minus 5. What cancels? X minus 5 cancel out. What answer do I get? Are you shocked? We're not shocked. See? Not bad. We're just doing the same thing over and over again. Try not to become a robot. Here's where you can become a robot, but try not to. All right. Well, I'm telling you to use this one. This is, don't get tricked. Remember, this is the alternate y2 minus y1 or x2 minus x1. And remember, that's this. As this point gets closer and closer to 2. So that's the alternate definition. Instead of using your delta x, you're using like the alternate one. You know what I mean? Yeah. All right, here we go. Oh, what's up? Oh, sorry. Don't worry, we're going to be done pretty quick. All right, here we go, guys. We're going fast now. I need f of a, so I need f of 4. So I go f of 4 equals 4 squared minus 2 times 4 plus 3. So let's see what this is. 4 squared is 16. 2 times 4 is 8, plus 3. The difference between 16 and 8 is 8, and then I add 3 to it, 8, 9, 10, 11. So I get 11. Now check my math. I make mistakes all the time. I need f of 4 plus h. So 4 plus h equals parenthesis 4 plus h close it squared minus 2 parenthesis 4 plus h close it plus 3. And there it is, guys. I'm just doing arithmetic. 4 times 4. 4 times h. But you're going to have two of them, so I'm going to write h times h. And then distribute the negative 2. 2 times negative 4, or negative 2 times 4 is minus 8, and then minus 2h. That's the biggest mistake. You forget the negative. Plus 3. All right, let's see. 16 minus 8 is 8, but I add 3, so I see 11. So 11 plus 8h minus 2h is, and then plus h squared. Hopefully I don't see any other mistakes. Let's see. No, I think we're good. All right, here we go. Limit as h approaches 0. Here's what I need. Be 4 plus h, so 11 plus 6h plus h squared minus what? All over h. Be careful. Don't be a robot. I know that you can be a robot real quick here, but try not to. What happens first? The 11's 0 out first. And now I can factor out an h. So I'm going to write another one. Limit as h approaches 0. Here's my h factored out. 6 plus h over h. What's going to cancel now? And then h is approaching 0. So what is this whole limit? So that's my slope. Cool, right? All right, now let's do the alternate. You already know the answer. So here it is. So all I need is f of a, which is f of 4. F of 4, you already said was 11. So here we go. Limit as x approaches 4. F of x, so x squared minus 2x plus 3 minus f of a. F of a was 11. All this is over x minus 4. Are we still okay? Okay. Positive 3 minus 11. So limit as x approaches 4 of x squared minus 2x, 1, 2, 3. Yeah, minus 8. Minus 8 over x minus 4. We have to factor two numbers that multiply to give me negative 8, but add up to a negative 2. 4 and 2. Which one's negative? Which one's positive? The 4 is negative. You're good. I got you. X minus 4, x plus 2. There it is. All over x minus 4. What's going to cancel out? Now can I do direct substitution? What's 4 plus 2? Are you shocked? Are you seeing how they're both the same answer? Because they're both the same thing, just a different way of thinking. The one on the left, you're making your delta x approach 0. The one on the right, you're making x approach that value. Cool? Okay. All right, 2 more problems, and we'll call it a day. We'll set you guys loose, and the activity is not due until Monday when we come back. Let me know if you have issues. All right, ready? All right, here we go. I need f of 3, so I'm going to write f of 3. 1 over 3 squared. 1/9. I need f of 3 plus h. Do you guys like doing a whole bunch of problems like this? Okay. 1 over 3 plus h with a square on it. 1 over 3 times 3. 3 times h. 3h, and then you're going to add 2, so 6h. Good. H times h. There it is. And those are the two that I needed. Limit as h approaches 0. I put this one first. 1 over 9 plus 6h plus h squared minus 1 over 9. All over h. Oh, child, this is going to be heavy. Not extreme, but yeah. Just algebra. On the right-hand side, you're going to multiply this by 9 plus 6h plus h squared over 9 plus 6h plus h squared. Right-hand side of the numerator. On the left-hand side of the numerator, you're going to multiply this by 9 over 9. All right, here we go. Let's see if I can fit it. Limit as h approaches 0. I did give you more room on the handout. I should have put more room here on this one. That's fine. 9 over, and I'm not going to distribute the bottom. I'm just going to leave it like this. Minus, okay, and 1 times anything is that same thing. So 9 plus 6h plus h squared over 9 parentheses 9 plus 6h plus h squared. I'm just trying to show all the details. All this is still over h. All right, I'll tell you what. I'm going to cancel this one, so we won't do it unless you want me to. That way I can keep writing with this down. All right, ready? I'm going to combine them. Don't forget, maybe put parentheses here so you can distribute that negative like that and not get confused. So limit as h approaches 0, 9 minus 6h minus h squared over, and I'm not going to distribute that 9. You could if you wanted to. You'll get the same answer. 9 plus 6h plus h squared. Close it. Keep, change, flip. Put the h right next to that. We still okay? All right, here we go. What zeros out from the numerator? Bam. Now that I've done that, here it is. One more limit. Limit as h approaches 0. I'm going to factor out an h. Negative 6 minus h. Close it. All over 9 parentheses 9 plus 6h plus h squared. Close it with an h on it. What's going to happen? These h's cancel out. Those specifically right there. And h is approaching 0. So I'm going to put a little arrow. 0, 0, 0. So I get negative 6 over what? 9 or 81? 81. Does that reduce? No, I don't think it does. I think, well, let's see. 6 over 81. 6 over 81. Yeah, it does. I'm a dummy. 2 over 27 negative. All right, don't worry, this is the last one. We already know the answer. So this one right here, letter B, better come out to this answer here. Do you guys see what we did? All right, here we go. Limit. Oh, let me change the color. What color have I not used? Purple. No, we used purple. Blue? Blue or black? You guys tell me. Blue. All right. Limit as x approaches 3 of 1 over x squared minus 1/9 all over x minus 3. This is going to be way easier. So you guys might like this one better for some situations. All right, here we go. I'm going to multiply this guy right here by x squared over x squared. I'm going to multiply this guy here by 9 over 9. And here we go. Limit as x approaches 3. 9 over 9x squared minus x squared over 9x squared over x minus 3. Limit as x approaches 3. I'm going to combine now. So 9 minus x squared over 9x squared over x minus 3. The numerator is the difference of squares. You can take this like x minus 3 over 1. So I'm going to do keep, change, flip while doing the difference of squares in the numerator. So here we go. Limit as x approaches 3. 3 minus x, 3 plus x over 9x squared. And I said I was going to do keep, change, flip. So 1 over x minus 3. I was tempted to just write x minus 3 next to the x squared, but I want you guys to see where it's coming from. Do you guys like that when I show the detail like that? Okay, I'll start putting more detail if I can, if I remember. Limit as x approaches 3. 3 minus x, 3 plus x over 9x squared parentheses x minus 3. All right, here we go. I can't do anything just yet because I have to factor out a negative to turn this into... So here it is. I put a negative on the outside, and I can choose which one to change signs. I'm going to change this one. So I'm going to put this as a positive and that as a negative. There it is. Everything is perfectly balanced, like Thanos said, as it should be. I'm kidding, guys. Yeah, the Thanos is bad. All right. What cancels out? Yeah, x minus 3, x minus 3. Now can I do direct substitution? Yes. Doing direct substitution, look what I get. I have a negative on the outside. 3 plus 3 is 6 over 3 squared is 9. 9 times 9 is 81. OMG. Negative 6 over 81. That's the same thing I had last time. Negative 2 over 27. Do you guys see how we're doing this? Tell me, Henderson. So now it's about practice. So this handout that you have, notice I give you a lot of space. It's about practice, guys. So I gave you 4 problems to do. It's probably going to take you a while because look at all the arithmetic you got to do, but you can do it. Try not to become a robot. Try to understand why we're doing what we're doing. You're doing the same thing over and over again. Did that make sense? Make it make sense? Make sense? All right, let me take attendance.